Now, I'm going to read, I'm going to see -3, 4, so yeah, I'm going to draw that. I started wrong though. Alright. Yeah. -3, 4. As I'm drawing that, I'm drawing the triangle. As I'm going -3, 4. That's my triangle. You go like -3 up 4. That's your triangle. What's the hypotenuse? 5. How'd you know that so fast?
Because it's a special.
A triple. It's a triple. Not a special. It's a triple. It can be special still, but it's not special. All right, then we're just finding the sine, cosine, tangent. Let's do.
We're getting out for that though.
You can do more if you want. Sine of theta is y over r. Why did I put y over r? Why did I not put just y?
Because r is not one.
It is not the unit circle. R is not 1, so I have to put y over r, 4 over 5. Cosine is x over r, -3x. Tangent, y over x. And again, I remember tangent because sine is y, cosine is x, so tangent goes y over x, like in that same order. Because I'm doing a positive over a negative, what's my answer going to be? It's going to be -4/3. So you don't put the negative at the bottom of the 3. Questions? Okay, next. Given tangent theta equals -5/4, so this is probably the only thing you haven't done yet for this year yet. Out of the stuff that we're doing in our assignment today, this is probably the only thing that's new today. Given tangent theta equals -5/4 and cosine is greater than 0, we have to find sine theta and secant. So first thing I'm going to do is start thinking, well, tangent theta is what formula? Y over x. And that is equal to -5/4. So since it's negative, what is negative? The x or the y? Or the y or the x? What's negative? Or do you know? You don't know yet. Because it could be -5 or it could be -4. Can it be both negatives? No. But then we keep reading and we see cosine is greater than 0. What do we know about cosine? It's x.
So it can't be 4.
So 4 has got to be positive. That means 5 has to be negative. So this ordered pair, now this is reduced, but this ordered pair would be 4, -5. So now we can draw it. So I'm drawing it 4, -5. That's how I make my triangle. Starting at 0, 0, going forward, then down 5. There's my triangle. There's my theta. I have to find just sine and secant. The formula for sine is y over r. But I don't know r. Pythagorean theorem.
Yeah.
Like what did you say?
But it's too early.
It's the Pythagorean theorem. 4 squared plus -5 squared equals r squared. It's also the distance formula. The distance formula? Remember the distance formula? We'll review it at some point. 16 plus 25 is 41. So this is the square root of 41. So now the sine of theta is y over r. So we are doing y, which is -5 over r, which is square root of 41. Can't leave it like that. Have to rationalize. -5 square root of 41 over 41. There we go. Rationalize it. Then we find the secant. I don't have secant memorized, but I know that secant is which one flipped? Cosine. So cosine is x over r. That means secant is r over x. So square root 41 over All right? Find the sine function at 4 quadrant angles. Sine of 0, sine pi over 2, sine pi, sine 3 pi over 2. So 0 is right here, pi over 2, pi, 3 pi over 2. All of those are on the axis. In order to find sine, you either need to know the angle or you need to know the ordered pair. When they're on the axes, I don't have like a reference angle. So instead, I need to just use the ordered pair. And it does not tell me if it's a unit circle, so the R value, it actually doesn't even matter. Doesn't even matter. So the R value, you pick whatever R you want. Anybody? Okay, we'll pick one. So 1, 0, and then this would be 0, 1, negative 1, 0, and then 0, negative 1. Before I put answers, I have to warn you. Other than people just not knowing the fact that sine is y, other than that, you know where people make mistakes on this? Other than just not knowing sine is y. But we know sine is y, right?
Yes.
They just put X and Y in the wrong order when they write their ordered pair down on the paper. Do you know how many people I graded papers and they told me that this ordered pair is 0, 1? It's ridiculous. So don't rush when you do this. That's such a silly mistake. You don't need to make that mistake. If you know that sine is y, correct your ordered pair right. Write the ordered pair correctly. So remember, sine of theta is y over r, and since our r is 1 for this example, we're just doing y. Sine is y. What is y in the first angle? 0. What is y in pi over 2? 1. What is y in pi? 0. And then, see, that is so easy. Don't make the mistake of just writing your ordered pair wrong. Okay. And then reference angle we talked about yesterday as well. So this is just review. It's positive, has to be a positive number. It's acute. What does acute mean? Greater than 0, less than 90. And then it has to form with the x-axis, with the horizontal axis. So I'm going to draw pictures. Make sure that I can visualize what's happening. If you can do this without a picture, great. But the people that don't do pictures are the ones that usually make the mistake. So 300 degrees is about here. I start at 0, go all the way around that 300 degrees. Now, the reference angle is the theta that forms with the terminal side and the x-axis. So it's how much is left over to get back to the x-axis. Can you tell me? 60 degrees, that's the answer. Negative 135 starts here and goes down and around. The reference angle is how much is left to get back to the x-axis. How much did you say? I didn't hear. 45. Is that what you said? So that is not a negative number, even though the direction I would be going is negative. You don't write it as a negative number. It's just like this is a triangle. It has a positive angle inside of it. The reference angle is always positive. And then this one. 2.3, what is that? Radians. How do you know it's not? There's no degree symbol, so you know it has to be radians. And because it's not written with pi, I'm going to start thinking radians in decimal. So right here is pi, but that is a decimal 3.1415926, right? And then 0 is here. So halfway through is 1.57 approximately. So 2.3 is about here. So the theta would be how much is left to get to the x-axis. How are you getting that answer? take your full 3.14 and subtract off 2.3, and you're left with approximately 0.84. Now that's just pretty hard, so I'm sure you need a formula for it, right? If you do, there are formulas, a different formula for every single quadrant, but I will tell you, I have never memorized these, nor will I ever memorize these. I just did it without a formula. But if you need a formula, if you know it's in the second quadrant, then this is how you would find your reference angle. Okay, but again, it's different for every single quadrant, so this to me is more confusing than just drawing the picture and like thinking about, oh, I just have to take that away from 360. Okay. Also, here is another formula that you probably learned last year, but I want to explain the math to you before I give you the shortcut acronym, which some of you already know. I'm going to explain the math to you. This has to do with each quadrant and which trigonometric function is positive or negative in each quadrant. So sine, let's just use the unit circle. It doesn't matter if it's unit circle or not, but sine is always what? Sine is y. Cosine is x, and tangent is y over x. Yeah. This is exactly what you should have learned last year. Again, this is reviewing. We really haven't gotten to much stuff that you haven't done, that you didn't do last year, other than the radians as decimals. Like the only thing you hadn't done last year. Or probably hadn't done. I didn't teach you all, so I don't know what you really did. But. So in the first quadrant, to get to any ordered pair in the first quadrant, we go positive x, positive y. So every combination of sine, cosine, tangent, or when you reciprocate them, they're still positive, because reciprocating doesn't change signs. Every combination, every single one of them is going to be positive. So we say all are positive in the first quadrant. When you get to the second quadrant, you first go left, then you go up. So x is negative. So anything over here that has an x is going to be negative in the second quadrant. So sine is positive, cosine is negative, and then tangent has a y over an x. So tangent has a positive over a negative, tangent is also negative. So I'm getting that from x, y. So the only thing positive in this quadrant is sine. And cosecant, because you flip it. And then third quadrant, you go left, which is negative, then you go down, both negative. Both x and y are negative, so sine is negative and cosine is negative. But when you put a negative y over a negative x, what does that happen? Positive. It's positive. So tangent is the only thing positive plus cotangent in that quadrant. And then finally, fourth quadrant, which this is the one that people get confused about. You just have to think about it. You go right, which is positive, then down, which is negative. So the only thing negative in this quadrant is y. So sine is negative, cosine is positive. Tangent has one negative, so tangent is also negative. Cosine is positive in quadrant 4. And then there's an acronym that people use to help remember ASTC, but you don't need the acronym, as you know where x and y are positive or negative. But if you need an acronym, you remember what it is. What is it? All students take calculus. Right. So if you need that, all students take calculus. That tells you what's positive. It's just a shortcut, so you don't have to go through all the process of actually thinking y is positive. Okay. You still need to know that y is positive in the top two halves. So you'll see. This will help, but it won't always help you. All right. That's easy. So that's all I'm going to do today. The rest of the notes we're going to do tomorrow. The assignment is kind of lengthy because you have to write like sine theta, cosine theta, like all of them. That's the part that takes a long time. But I wanted to stop early so that you can get time in class to work on it. I'm not stopping early so you can Snapchat. Oops. I'm not stopping early so you can play around. I'm stopping early so that you can have time to work. And then so I can answer questions if you have them. Was that the one we did yesterday?
No, we give it to us last week.
Is that the one that I put on Canvas and I said check your answers? Let me stop the video.
It's just been sitting in my.